All right, so we are going to continue exponents and all the rules. So this is going to be 5.3, and this is multiplying. And my computer, I updated it this morning, and it's giving me lots of grief. All right, so we are multiplying polynomials. So remember, a polynomial is a monomial, binomial, trinomial, or any more than that. So first off, we're going to talk about just multiplying monomials. So remember, a monomial is just one piece, like 5x or maybe 2x squared. These are monomials because they're just one term. So if I were going to multiply 10x times 9x, so if I multiply 10x times 9x, you multiply the numbers, and then you multiply your letters. So if I were to multiply the numbers and then multiply your letters. So 10 times 9 is 90, and then x times x, you have to use the rules from 5.1, which we would just add the exponents here, so it would be 90x squared. Okay, in this one, this is not 8.3. I missed an exponent there. All right, so here what we're going to do is we're going to multiply the 8 and the negative 11. So 8 and negative 11, and then we're going to multiply the bases because they're both x's. So remember, when the bases are separate, you add the exponents. So negative 11 times 8 is negative 88, and then 3 plus 7 is 10. So it would be negative 88, x to the 10th power. So that's all there is when you're multiplying monomials. Multiply the numbers, then add the exponents. All right, so what about distributive property? So what if I wanted to multiply 3x squared and negative 2x? Well, this is what we just did. This is multiplying your monomials. So we're going to multiply the numbers. So we got 3 times negative 2, and then we're going to multiply the letters, which is x squared times x. Now I can't add them, I can't combine them, but I can multiply them. Just because they're different, it doesn't matter when we're multiplying. So remember, this has an exponent of 1. So we're going to get negative 6x cubed, because 2 plus 1 is 3. All right, now here we're going to look at multiplying a monomial by a binomial. So what I always do with these is I'm like, okay, 4x times 4x cubed. So I would do 4x times 4x cubed. Then I would do 4x times 8. So now I have 4x times 8. So now you just multiply the two monomials. So 4 times 4 is 16. And then x times x cubed is x to the 4th. Now multiply 4 times 8, which is 32. And then you just have your x because there's nothing to multiply by. So then that would be your final answer. And yes, you can multiply a monomial by a trinomial. You can multiply a monomial by anything. So here I would go negative 5x squared times 2x squared. So type it all, write it all out, and you don't have to do it like this. I would do it this way. This is the short way, and then I'm going to show you all the steps as well. So I would go negative 5 times 2 is negative 10. X squared times x squared is x to the 4th. Then I would multiply this one. Negative 5 times 7 is negative 35. X squared times x is x to the 3rd, because remember, you're adding your exponents. Then I would multiply the last piece. Negative 5 times negative 2 is positive 10. And then I have x squared because there's nothing left. And this is your answer. Okay, you can't combine them because this is a 4, a 3, and a 2 as exponents, so they're unlike terms. But if you wanted to write it all out, so the outside term times the first piece, the outside times the middle piece, and the outside times the last piece. And then here, negative 5 times 2 gives us that negative 10x to the 4th. Negative 5 and 7 would be our 35, and then negative 5 and 10. This should be positive. This is a typo there. So that would be our final answer. And so it's either way. I am a big arrow drawer, so I like to do the arrows as to what I'm doing. Answer done, or you can write it out like this if that's the way that makes most sense to you. Either way is completely okay. All right, so now what happens when we multiply two polynomials? So now we're not just taking 1 times 2 pieces, we're going to do 2 pieces times 2 pieces. So what that looks like is y plus 5 times y plus 7. So some of you may remember from school when you were younger, they said use the FOIL method. If you don't remember the FOIL method, so the FOIL method, F is for first. So you would multiply the first terms. So y times y. So y times y. O is for outside. So now you would multiply the outside pieces, y times 7, so plus y times 7. I is for inside, so I would do 5 times y, so plus 5 times y. And L is for last, so 5 times 7. And then you would, y times y is y squared. Y times 7 is 7y. 5 times y is 5y. And 5 times 7 is 35. And then you can combine these two because they're like terms. Y squared plus 35y plus 35. And then, oh, not 35y, sorry, that's a 12. We're adding, not multiplying. 12. 7 plus 5 plus 5 Reynolds is 12. And then 5 times 7 is 35. And there is your answer. The short version of this, the way I do it, I normally do not do this step here. It's a matter of what makes sense to your brain. Like I said, I'm big with the arrows. Y times y, y squared. Y times 7, 7y. 5 times y, 5y. 5 times 7, 35. And it gets me right there to that step. So I just don't write this one down because I use the arrows. But like I said, either way, whatever way makes sense to your brain. All right, so now remember when you have something squared, it means you're multiplying it by itself that many times. Like 3 squared means 3 times 3. Well, what is 3x plus 4 squared? Well, that means 3x plus 4 times 3x plus 4, because you have to write it however many times the exponent is. So now basically what I've done is you just have the same thing repeating, but yet it looks like this, where there's 2 of them. So you would do your 3x times your 3x, so your first. So 3x times 3x. And then this is actually, let me kind of backtrack here. They're going to do the 3x and they're going to multiply it by both pieces so that you have the monomial times the binomial, like the first or second slide that we did. And then they're going to do it with the 4. So then they're going to do the 4 times this, and the 3 times this, and then 4. Okay. Again, I would just do the arrows. 3 times 3 would be 9x squared. So first, so outside would be 3 times 4, which would be 12x. And then inside, 4 times 3, which is 12x. And then 4 times 4, which would be 16. So I would do it as 3x plus 4 times 3x plus 4. First, outside, inside, last. Kind of makes a smiley face if you draw your arrows. Here's the guy's nose, here's his mouth. Anyway, you can do it that way, where you come up with this, and then of course these two are like terms. So 9x squared plus 24x plus 16, and you'd be done. So that would really be all the space you would need. If you want to do it this way, where it's called double distribute. So you take your 3x times the whole term, then you take the 4 times the whole term, and then you this times this. So 3x times 3x is, and then 3x times 4, and then you got 4 times 3x, and you got 4 times 4. And then you combine your like terms and all that. So now we got 3 times 3, which is 9x squared, plus 12x, plus 12x, plus 16, which is exactly the same thing that I got here, doing the first outside inside last. And then of course you would combine your like terms. I don't know how I missed all of these. All right, and then you're left with the answer, which is exactly what I have up here. So always check those middle terms. They should be alike. All right, let's try it again. So we got 5x minus 2z squared. So that means 5x minus 2z times 5x minus 2z. Using my shortcuts, I would do 5 times 5. So 5x times 5x is 25x squared. 5x times 2z is negative 10xz. Inside, negative 10xz, because negative 2 times 5 is negative 10, and x times z is just xz. And then your last terms, negative 2 times negative 2 is positive 4z squared, because z times z is z squared. These two are like terms, xz, xz. So I'm left with 25x squared minus 20xz plus 4z squared. And there's the answer. But if you want to take it like they did on the last problem, 5x times the second monomial, or binomial, sorry, minus 2z times the binomial, and then distribute. 5 times 5 is 25, 5 times 2 is 10. Negative 2 times 5 is negative 10, negative 2 times negative 2 is positive 4. And then you would combine your like terms, and you are left with the exact same thing we had up here, 25x squared minus 20xz plus 4z squared. So it's just a matter of, do you want to double distribute and then use the distribution property there, or you can do the arrows. It's totally up to you. I just want to make sure I show you both ways. Okay, same thing applies here. You can do, you're going to take your A and you're going to multiply it by every single piece. 1, 2, 3, just like if it were a monomial. Okay, so you would do it like this. And then you would take the second piece and you would multiply it by all 3 pieces. So you would be having 2 times a cubed minus 3a squared plus 7. Then you would distribute. A times a cubed is a to the 4th. A times 3a squared is negative 3a cubed. And a times 7 is 7a. 2 times a cubed is 2a cubed. 2 times negative 3a squared is negative 6a squared. And 2 times 7 is 14. So now here you have to think, okay, I'm done multiplying, so now I need to combine my like terms. So I have a to the 4th. You always want to start with your largest exponent. There are no more a to the 4ths. So you bring it down. Then I've got negative 3a cubed, and there's a positive 2a cubed, so I can combine those two. Negative 3 plus 2 is negative 1a cubed. Then I have a, and there's an a squared, so those are very different. So the next exponent after 3 would be 2. So then you would have negative 6a squared. Then you would do the exponent of 1. And then you have just your 14 left over. So there's your answer. It's very long and it doesn't look like it should be an answer, but it is. Okay, so don't feel overwhelmed if your answers look strange or weird. It's okay. All right. Now, what about multiplying vertically? So we did that earlier where we added them vertically, but what happens when you multiply vertically? So just like, let me go back here for a second. Just like if you have 23 times 5, 5 times 3 is 15, carry the 1. 2 times 5 is 10, plus 1 is 11. So you did this number first, then you did this one. You're going to do it the same way, but this time you're going to have letters. So a convenient method for multiplying polynomials is to multiply vertically. Vertically, and it's similar to the way we multiply real numbers. So if I were going to multiply these two, it would look like this, but the one with more terms in the top, just like I did 23 over 5, because 23 has more numbers than 5. And then you're going to go 5 times 4, which is 20. And then you're going to go 5 times 3y, which is 15y. And then you're going to go 5 times 2y, or sorry, 2 squared. Oh my God, y squared. I can't talk this morning. And that would be 5y squared. So that takes care of that. Now you have to do the other number. So 2y squared times 4, which is 8y squared. So you're going to want to line it up with the y squared. 2y squared times 3y is 6y cubed. You're going to put it in front because it doesn't match those two. And then you're going to have 2y squared times y squared, which is 2y to the 4th. And then if you'll look, you'll see how it's all lined up for you. This doesn't have anything added with it. The 6y cubed doesn't have anything added with it. These are both y squareds, so 13. And then these two have nothing, so you just bring them down. And then this would be your final answer. So again, it's preference, whether you want to do it horizontally or vertically. It doesn't matter. Both ways will get you the answer. All right, and that is the end of 5.3. I will get 5.4 done, and I will see y'all on Thursday.